All right, thanks, Sam. I assume that you can hear me okay.
Yes, loud and clear.
Great. My name is Kate Hassett. I'm from the OECD. I'm working in the Environment Directorate, and really pleased to be able to present our recent work today. This work is based on analysis of the energy-related data coming from the OECD EPIC Survey. As Sam mentioned, I'll be presenting today along with Helene and Kavya, who have contributed to this work. Just a note that this report is actually, the fruit of a collaboration between a number of contributors, including those in academia, but also others at the OECD. So the report follows an overview of the survey results that we published last year. So the results are based on the third round of the OECD survey on environmental behaviors, environmental policies and individual behavior change, otherwise known as EPIC. The survey covers 9 countries and 17,000 households within these 9 countries. And it covers 4 thematic areas, notably energy use, transport, waste practices, and food consumption. Any one respondent saw only 2 of these blocks, so to speak. Otherwise, the survey would have been much too long. So as a result, the thematic analyses that go to do an in-depth analysis of each of these areas are based on a sample size that it's approximately half of the total sample size shown here. So just some basic information about the survey implementation. Our target sample was the general public over 18, and specifically those who reported that they had full or partial responsibility for some household expenses, things like utility bills, appliance purchases, etc. It was administered online. Participants were provided a modest compensation for completing the questionnaire. And recruitment was carried out by Ipsos, our survey provider that maintains a panel. And quotas were established for gender, age, region, and income in order to ensure representative samples. We took a number of steps to ensure the quality of the responses that we were analyzing. So we dropped notably observations that that were completed in too quick of a time. So those respondents who were moving too quickly through the survey to really be able to engage meaningfully with the questions, and then other indications of non-attentiveness, essentially. And then our overall dropout rate was 26%. Finally, we implement post-stratification weights to correct for any eventual deviations from the population in terms of gender, age, region, and income. So just first a few takeaways from the descriptive analysis that was published last year to provide some context. So overall, across the responses from the entire survey, we see evidence of some cognitive dissonance. Households express a willingness to change, but they also say that they don't want to pay for it. Environmental considerations don't appear to play a major role when it comes to certain behaviors, in particular food consumption and transport habits. In those areas, even those who were environmentally concerned didn't report engaging in particularly more sustainable ways. Households, unsurprisingly, tend to engage most in environmental behaviors that are lower effort, lower cost, and more convenient. And so one central cross-cutting finding is that 3 key factors are important in driving households' decisions, and that's affordability, availability, and convenience. So these findings overall reinforce policy priorities such as making sustainable options available, providing financial support, and improving the convenience of making sustainable choices. So the work on the energy-related data is motivated by the fact that a large share of emissions are generated by the buildings sector. It's also motivated by the projected growth in renewable energy consumption that will be required in the building sector in order to achieve climate objectives. So the net zero emissions scenario from the IEA, for example, projects that 46% of total energy consumption from buildings will need to be renewable by 2030. And that's compared to the 16% that it was in 2022. And beyond technological advancements, the IEA, for example, also estimates that behavior change can contribute to reducing energy demand by 10% by 2050. And finally, we saw that electricity consumption fell in Europe over the last couple of years. Although this was due in part to mild winter temperatures, it was also due to high energy prices. And this points to the role of behavior change in reducing energy use. However, we note that policy efforts are needed to ensure that these changes are lasting on the one hand, and also that they don't come at the cost of lower welfare. So the geographical scope of the EPIC data allows us to shed light on the relative importance of the barriers that households are facing to making more sustainable choices with respect to their energy use. And this can ultimately inform the prioritization of the components of policy portfolios that aim to reduce the energy intensity of the residential housing sector. So the report aims to provide insights regarding one kind of key research question, which is essentially how can public policies better support households in reducing their energy use, in investing in low emissions energy technologies, and in switching to renewable electricity. And we'll do this by assessing, on the one hand, the determinants of household behavior with respect to these outcome variables above, and also their willingness to pay for renewable electricity. So just a preview of some of the findings. We find that tenure status and residence type have a strong impact on energy efficiency investments. We also find that financial considerations and environmental attitudes are both important drivers of household engagement in saving energy and in their installation decisions. And we find that households are also willing to pay something more for renewable energy. And finally, we find some cross-country variation in reported behaviors and also in the extent to which households are willing to pay more. So we'll return to the policy implications of some of these findings at the end of the presentation. But with that, I think the time has come to hand it over to Helene and Kavya for more information on their contribution to this work.
Thank you, Kate. So my name is Helene Ahlborg, working at Chalmers University in Sweden, and we'll talk a little bit, along with Kavya, my colleague, will talk a little bit about the results, and then Kate will come back also, and we might even ask her to come in and clarify if we forget to say something important. So basically, what we wanted to understand is both who can move, who can change behavior, and what are the barriers to changing behavior, because we're interested in how to speed up energy transitions in various countries. So we know that different households are doing different things, and some are already doing a lot, as much as they can perhaps, to reduce their energy use and thus their emissions, whereas other households are lagging behind in terms of how whether or not they adopt more efficient technologies, whether or not they are engaging in conserving behaviors. So we needed to understand both what are the different types of behaviors, but also then in order to understand what groups could do more and what could policy then do to make that happen, facilitate it or push it. So the logic here was to start from the possible ways in which you can cut your emissions, reduce your energy use. And so either by engaging in energy conservation behaviors or by investing in low emission energy technologies that either mean you switch to a renewable energy source or you switch to an appliance or device that is more efficient, thus lowering the use. So we created these, in the analysis, we used latent class analysis to define household profiles. And this is based on the patterns in responses around behavior. And it's worthwhile to note that this is reported behavior, so it's not observed behavior, so self-reported, which means we have to be a little bit careful about drawing conclusions. The other aspect of this is, of course, that we're now talking about an aggregate of sort of behaviors across the country sample. We also show data for how the countries differ from one another, but much more needs to be done to actually look in detail for respondents within each country. So you'll see a bit of both in terms of across the entire sample and for different countries. So the energy conservation, it's based on items in the survey where it's basically asking questions, how often you do the following in your daily life. And it includes turning off lights when leaving a room. It has to do with laundry and dishes. It has to do with minimizing the use of heating and cooling and hot water use. And then the answer options were basically never or rarely or often or always. And on the investment side, it was basically asking people whether or not they have installed any of the following items during the past 10 years, which we saw as a reasonable time period to ask about. And then this comes into different types of appliances, but also work done on the home in terms of improving or reducing the energy need in the home, and also switching to new sources for electricity, for example. We can take the next one. And so within the latent class analysis then creates or proposes classes, and we decided to go for 2 types of classes for the energy conservation aspect. So basically dividing people into either being non-conservers or conservers based on the answers they give to these questions. So the never and rarely conserve, that ends up being a 35% of the sample. These are, of course, then prediction of the likelihood of falling into a class rather than the actual group size. And then the conserver group that answers that they often or always conserve, it's bigger, it's 65%. And then along the different, what you see to the right here is the result across the different countries where Belgium is used as the baseline country. And for Belgium, in this case, the answer when it comes to the share of conservers is actually higher than the average of 65. So it's 73 percentages more or less that answer that fall into the conserver class in Belgium. Meaning that, for example, Sweden here, which is a minus 20%, is around a little bit more than half of the respondents that fall into the class of non-conservers. And that's interesting then to understand why Sweden, Canada, for example, here in the United States, we're seeing lower levels of conserving behaviors in these countries. Whereas in the UK especially is standing out as having a higher share of conservers among the population. And then there are different things to observe in this 2-class model. So there are differences across these different specific behaviors that people can engage in, and we'll show you a slide for that. For example, for Sweden, one possible explanation for why conserving behaviors are are not seen to the same extent can be both that it's a country with a cold climate and also well-insulated houses, but also historically very low prices. And also the fact that we have a very high share of renewable energy here, which means that many of us know that our electricity comes from a clean source, meaning that we don't have the sort of environmental motivation to use less. Whereas in a country where you know that your electricity might come from a coal-fired power plant, that would, for some people, motivate them to care more about engaging in conservation behaviors. But it's also across the entire sample, there are differences in terms of age, where in particular older respondents are more likely to fall into the conservation class. But also that the richer income quintile is less likely to do so. We have measures in the analysis for energy poverty, and we see that people who are then either identifying themselves or objectively understood to be energy poor are also engaging to a higher extent in conservation behavior, which is what we expected. We can see a positive influence of environmental concern and also a sense of personal responsibility. So in contrast to what Kate said about transport and food, here we can actually see that for those who express as an environmental concern or a sense of personal responsibility, that they are also more likely to engage in conservation behaviors. And there's a gender effect to this. So it's both that women to a higher extent express these attitudes, but also that for female respondents, this is then more likely to also result in actually doing energy conservation behaviors, whereas that effect is not there for men. So that's an interesting gender difference in the results. There are other things to note around the various types of norms, but also some differences between urban and rural dwellers, but we can maybe come back to those details later. So we can take the next slide. Kavya.
Yeah, so we've done something similar for the investment as well. So as you can see, we have 6 classes of investors that the LCA has given. So a closer look at these classes gives very interesting pictures. For example, the class of super investors, they're basically a group who are not motivated by environmental concerns. But this is a group that shows a lot of faith in technology rather than sustainability, because we had a specific question which said that environmental issues should be dealt through technological solutions. There's also an interesting factor here is that the super investor groups are high income, young, and generally male respondents who fall into the super investor category. Now, if you look at the other groups, like say the don't invest households, they exhibit very less environmental concerns. Whereas the low-cost investors are also high-cost high investors. Low-cost investors also have high income, and they also exhibit a certain amount of faith in technology. Now, if you move to the next slide, where we can we move to the next slide? Okay. Yeah, where we look at the different factors that influence the likelihood of being in the invest when possible group versus the don't invest group. We see similar trends with respect to age when you think of the curtailer class. So age is indeed a positive driver of invest when possible category, but income is also a positive driver here as opposed to curtailment, where we see that higher incomes leads to lesser amount of curtailment. Then again, concern around environmental factors is a driver of investment, and a sense of personal responsibility where you feel that you're personally affected by environmental challenges and climate change kind of positively affect investment decisions. It's also interesting to see the country fixed effects, because you see that again, Sweden, many of the countries there are showing very low propensity to fall in the invest when possible group. The only countries that show a positive correlation is UK and Netherlands. And again, we can compare UK to the curtailment slides, where it also ranks high on the basis of falling in the curtailment class. And here you also see UK more in the investment possible group. So Israel here becomes an outlier because it has a very low proportion of households that indicate presence in the invest when possible group. So if we move to the next slide. Yeah.
So then I'll take up again around a little bit more details around the conservation behaviors, where, like I said, income, the higher income has a negative effect on the likelihood that you'll engage in these behaviors, whereas we have both environmental concern, basically being worried about the environmental issues, sense of personal responsibility, but also a feeling of subjective vulnerability to climate change and its future effects, in this case, have positive effects. You see here we have subjective energy poverty, which is households that say that they cannot use as much energy as they would need to. And then we also have the objective energy poverty group, which make this statement, but then we also see that they belong to a low income group. So they're basically considered to be among the poor in their home country. So this then has a positive effect around conservation behaviors. Attitudes also matter. So we have looked at some of the barriers here, feeling that change is unnecessary, lacking knowledge, or having it, but also a sense of conflicting goals. And for conflicting goals is one of the stronger attitudinal barriers to engaging in these behaviors. And that can basically be people who feel that they should, but then for various reasons, maybe they forget about it, or it's would compromise their comfort at home. They have other reasons why they do not engage in these behaviors, even though they want to. What this tells us a little bit is that there are, with measures that would improve the financial benefits that we could get from energy conservation behaviors, that could have an impact, and maybe also for that group that is currently not engaging because they have higher incomes. You need to think about how to do that. But it's also about alleviating psychological barriers and maybe strengthening this sense of personal responsibility. And that should be then having potentially a positive effect. But then again, you would have to look within each country and see what these numbers are, because within this sample, we then have important differences within countries that needs to be unpacked before you can go find the right policies. Next slide. Kavya?
Right. So when we look at the barriers to technology adaptation in households, we see a lot of relationship between the tenure status, that is whether you're an owner or a renter. So there could be various factors that influence the installation of, say, for example, highly efficient energy appliances. One of the reasons could be the market failures, which is the evident financial and structural barriers that the tenants face when investing in highly energy efficient appliances. There is also a difference in the information and the incentives that are available to both landlords and the renters when it comes to the installation of low emission energy technologies. So as a result, the problem often becomes that landlords have very low incentive to invest in low emission energy technologies because they will not be the ones who are actually going to recover the costs. So this kind of shows us that there is a possibility for a greater policy intervention here, where the tenants either have more flexibility or the landlords are, of course, mandated by policy to install in energy saving technologies. So if we move to the next slide, we can clearly see the effects of various variables on the different factors. So for example, if you look at income, you see that the presence of credit constraints of lower income households, they can actually limit the capability of households to make upfront investments in energy saving techniques. Then again, we have low-income households who might be facing additional problems because of the low quality of the housing stock. There are also various transaction costs that can influence the installation of low-income households to install in technologies. Then again, a sense of personal responsibility have a greater context in the when those households that feel more responsible in bringing out their contributions to environmental change or climate change. Taking up those responsibility actually helps those households to invest more in energy saving techniques. So a sense of, but then you can also see that the influence of environmental factors is not something that is over and above income. So again, financial reasons become the major factor which influence the adoption of technologies. And income is also a very important determinant when it comes to highly efficient technologies and highly cost intensive technologies. If you look at age, you see that with increase in age, there is a tendency to invest in technologies that are less cost intensive and also older technologies. As age has a negative influence when the technologies that are to be installed are quite new to the market and it's not widespread. So yeah, we can move to the next slide now, please. Kate?
Yeah, thanks, Kavya. So I will talk about another portion of the energy section of the survey. So in the overview report, the descriptive analysis, we saw that there appears to be a high unmet demand for renewably generated electricity. Approximately 40% of households overall indicated that they have not been offered this option, but that they would be interested in it if they were offered the option. So next we'll be presenting results of the discrete choice experiment that was included in the survey, which estimates households' willingness to pay for such an option. So here's the choice card that respondents would have seen. So it asks them to select essentially between, I'll focus our attention here on the choice that they are asked to make, which is between the current provider and two alternative providers. And the current provider is characterized by the average price per kilowatt hour and emissions intensity per kilowatt hour in the country in which the household resides. And the two alternative providers are greener. They emit less emissions per kilowatt hour, but they're also more expensive. And so analyzing the data that this experiment generates allows us to estimate willingness to pay for reductions in greenhouse gas emissions intensity of households' electricity consumption. So we find that households are willing to pay to reduce the emissions intensity of their electricity consumption. All of these values are positive. But we do see that this willingness varies considerably across countries. So for a 10% reduction in greenhouse gas emissions intensity, households are willing to pay between about 1% and 9% more per kilowatt hour. So these differences could be driven by a variety of factors that vary at the country level and that aren't explicitly controlled for in the analysis. So this can include differences in the assumptions that households may be making about the source of the renewable electricity. In the literature, differences have been found in willingness to pay across different types of renewable energy sources. It could also be due to differences in the average emissions intensity of electricity in each country, as Helene was describing earlier. In Sweden, for example, where average emissions intensity is already relatively low, this may translate to a lower willingness to pay for marginal additional reductions in emissions intensity. It could also be due to price fluctuations that different countries experienced in 2022, as well as existing levels of government support for renewables, differences in social norms, public education and information. So a combination of all of these factors is likely to explain the variation that we see in the values here. We also find evidence of a status quo effect among some groups. So this is essentially the tendency to stick with the current provider, regardless of the impact of price or greenhouse gas emissions intensity. So we in particular find this effect among women, among those who are older than 55, those who live by themselves, and those with high electricity bills, which is somewhat unsurprising given that the alternative providers are more expensive. However, this effect should be, considered to be separate from the effect of price. So one explanation for a status quo effect in general is the general inconvenience associated with switching providers. We also see the opposite effect among some groups, notably those who are have obtained a higher education and those who are environmentally concerned. These groups are in fact more likely to switch to one of the alternative providers. So these results regarding the status quo effect, they suggest that making green options the default options could be one effective way to increase the use of renewably generated electricity. So we also used the results of the choice experiment to assess the impact that a carbon tax could have on households' propensity to choose greener electricity options. So here we see the impact of various levels of a carbon tax on the probability that a given household will choose the current provider, so the dirty provider, so to speak. So as the carbon tax level increases, we see declines in the probability of choosing the current provider. So we do see differences in the extent to which a carbon tax impacts these probabilities. We see in countries like Sweden, for example, the tax has a very small impact, but in Israel, for example, it has a larger impact. And so we consider there to be at least two drivers of the impacts that we see here. One is differences in households' price sensitivity across countries. And the other is differences in the emissions intensity of electricity consumption across countries, because this means that a given carbon tax will have a different impact on price across countries. So to remove this emissions intensity effect, on the right, we plot the change in choice probability by the change in price only. And so this is in an effort to kind of isolate the potential differences in price sensitivity. So in this graph, we see that households in different countries are characterized by different baseline propensities to choose the current provider. So this is evident by the height of the left-hand side of the bars across countries, which are different. But when it comes to the slopes of expressing household behavior across countries, we see that, beyond the differences in kind of the baseline propensity to choose the current provider, they're relatively similar in their price sensitivities across countries. So I will wrap up with some key observations coming from the analysis and the policy considerations that could be considered to issue from these observations. So one observation that Kavya covered is that those who rent and live in apartment buildings are less likely to install low emissions energy technologies. And this points to the importance of alleviating the installation barriers that exist for renters and apartment dwellers. We also find in the analysis that income impacts energy conservation as well as technology adoption. And the importance of income in determining, both of these behaviors signals the importance of financial considerations generally to households in making these decisions. And so this also points to the role of improving the financial savings associated with energy conservation and providing financial support for installing low emissions energy technologies as strategies to support households in saving energy more and also installing lower emissions energy technologies. And as Kavya and Helen described, we also see that environmental concern and a sense of personal responsibility are significant determinants of energy conservation, but also of investment in technologies. And so to the extent that awareness campaigns can be expected to kind of foster a sense of environmental concern and personal responsibility, they could also be expected to generally support energy conservation, greater energy conservation and investments in technologies by households. And finally, throughout the analyses, as we've seen here, and the willingness to pay results and the reported behaviors, we see considerable variation across countries, which points to the role of considering local policy context in more effectively encouraging sustainable choices. So to wrap up, in doing this work, we've identified a number of areas that would seem ripe for further exploration, notably exploring country level differences in more detail, that is, running these analyses at the country level. Currently, the analyses are run in a pooled manner, allowing for some basic cross-country differences, but we could explore these differences in more detail by conducting the analysis at the country level. We could also explore the relationship between policy support, trust in institutions, and information sources in households' sustainable choices and even in their willingness to pay for renewable electricity. And as Helene also mentioned, we could explore heterogeneity within the attitudinal impacts that we found here. So in other words, the extent to which attitudes may have different impacts on behavior among different groups. So preliminary analyses have shown that for some behaviors, a sense of personal responsibility has an impact on, it drives this behavior for women, for example, but not for men, as Helen was mentioning, and also for older respondents, but not for younger respondents. So I will now hand back over to Helen and Kavya to describe some directions of future work that they're currently exploring.
Thank you, and we'll keep it very short. So I'll just do this first slide, and then we can see if we have time for more detail. But we're currently working also with a different method because we're actually very interested in also in the observed data in terms of who is falling into different groups. So we're now moving a little bit further with identifying and classifying user groups based on their reported behaviors. And we're doing this because we're interested in within each country to identify who is potentially falling behind in the transition and who should be moving, who could be moving, such that we can target a policy to groups where there is scope for effectiveness. So among the things we're looking at is what we call the high impact user groups, basically people who are using a lot of energy in their daily lives and who are not engaging much in either conservation behaviors or investment behaviors. So this group is pretty small in the sample, but they could still be potentially important given the high emission for those households. We're also interested in groups of households that are doing some that could do a lot more and where the scope may be pretty large. For example, families with many kids that have a high energy use, but have multiple barriers to conservation and to investments because of competing needs, etc., where we then want to understand better who are they, what are both their attitudes and their capabilities of making changes in order to see what is the scope if we can tailor policy to target this group and make it easier for them to act on their attitudes, for example. But similarly, we have a small portion of the sample that comes as energy poor, but it's still really important to understand that group to make sure that these people are not then impoverished further by new policies. So what we are doing now is to look more closely at the observed data rather than latent classes, and to look within these countries to be able to see where there is scope for effectiveness in terms of actual emission reductions, but also what would be socially acceptable for these groups. So that's where the work is currently, and we'd be happy to answer more questions. Over to you, Sam.